It arrived without warning. A whisper in the dark, detected on July 1st, 2025, by the vigilant electronic eyes of the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile. At first, it was just another faint point of light moving against the stellar tapestry. But this point of light was different, moving too fast, its velocity suggesting origins far beyond the gravitational boundaries of our Sunday. Astronomers watched, their calculations flowing through supercomputers, and within 24 hours, a startling conclusion was reached. This visitor did not belong to us. Designated 3I divided by Atlas, it was only the third interstellar object ever confirmed to have entered our solar system, its trajectory hyperbolic. A cosmic arc that would swing it around our sun, just once before, flinging it back into the void from which it came. It was traveling at a staggering 130,000 miles per hour, over 209,000 kilometers per hour, a velocity so extreme it could only have been accumulated over billions of years adrift in the interstellar medium, accelerated by the gravitational nudges of countless stars. This was not just a visitor. It was an ancient mariner from an unknown shore, carrying with it the chemical fingerprints of a stellar nursery we will never see. Thank you for being with us. Please subscribe and leave a like. Initial observations from the Canada-France-Hawaii telescope revealed a nuclear radius of around 10 kilometers, assuming the low reflectivity of a typical asteroid. But 3I divided by Atlas was not a typical asteroid. It began to show activity, a faint coma of gas and dust that identified it as a comet. Yet the anomalies were just beginning to surface. The first clue that something was profoundly unusual emerged when astronomers calculated its orbital plane. While it traveled retrograde against the flow of our planets, its path was tilted by only 5 degrees from the ecliptic plane, the flat disk on which all our worlds revolve. Harvard astrophysicist Avi Loeb, a central and controversial figure in this unfolding story, was the first to highlight the sheer improbability of this alignment. Direct source attribution. The likelihood for that coincidence out of all random orientations is 0.2%, Loeb stated in his analysis. For an object wandering randomly through the galaxy to enter our system and align so perfectly with our planetary plane was, in his view, a statistical near impossibility. It was as if it had aimed for us, threading a cosmic needle with impossible precision. In billions of years of galactic wandering, what trajectory could naturally produce such alignment? The question lingered as telescopes continued their observations. Then came the images from the Hubble Space Telescope, and they revealed something that defied cometary physics. A jet of material, an extended glow, pointing not away from the sun, but almost directly toward it. Comet tails are formed by solar wind and radiation pressure pushing dust and gas away from the nucleus, creating the iconic sweeping tails we see in night skies. An anti-solar tail is a known, though rare, optical illusion caused by the geometry of observation, but this was no illusion. Later observations from the Tide Observatory confirmed it. A faint jet physically extending some 6,000 kilometers from the nucleus straight into the glare of the star it was approaching. The object was actively pushing material against the solar wind, expending energy to drive a plume of matter toward the very source of radiation that should be blowing it backward. No known natural mechanism could explain this behavior. Every comet humanity had studied obeyed the iron laws of radiation pressure and solar wind interaction. But 3, I divided by Atlas, seemed to be playing by different rules entirely. The mystery deepened as space-based telescopes turned their most sensitive instruments toward the visitor. The James Webb Space Telescope, humanity's most powerful infrared observatory, analyzed the object's chemical makeup and found it was overwhelmingly composed of carbon dioxide, nearly 87%, with roughly 9% carbon monoxide and only 4% water. This is the inverse of comets from our own solar system, which are rich in water ice. Their surfaces frosted with the frozen oceans that seeded Earth's seas billions of years ago. The extreme carbon dioxide dominance suggested 3. I divided by Atlas was born in a star system profoundly different from our own, perhaps orbiting a star with different metallicity, different planetary dynamics, different chemistry in its primordial disk. It was a chemical ambassador from an alien stellar environment, and its composition told a story of formation conditions we could barely imagine. But it was the trace elements that would ignite a firestorm of controversy. The James Clerk Maxwell Telescope detected a vast asymmetric coma of hydrogen cyanide stretching 180,000 kilometers across, a poisonous veil trailing behind the nucleus like a banner of chemical warfare. Then, in data released just in the last 48 hours from the Keck Observatory in Hawaii, came the bombshell that would fracture the scientific community into opposing factions. The analysis, led by a team including Avi Loeb, found the object was emitting nickel at a rate of approximately 4 grams per second. This in itself was not unheard of. Trace metals have been detected in cometary emissions before. What was unheard of, what was considered impossible by conventional cometary science, was that it was emitting nickel without the corresponding iron that is always, without exception, found with it in meteorites and comets throughout our solar system. In every natural sample humanity had studied, nickel and iron are inseparable companions, forged together in stellar cores and mixed thoroughly in the debris clouds that form planetary systems. The data showed a plume of a specific compound, nickel tetracarbonyl, being released into space in a purified form that had no precedent in astrophysics. This substance is not known to occur naturally in space. On Earth, it is an industrial product, a volatile compound used in the Mond process, a critical technique in manufacturing and aerospace for applying pure metallic coatings to precision components. It is the chemical signature of refinement, of industrial processing, of technology. The interstellar visitor was leaking a substance that, until now, was only known to be manufactured in human factories. The implications were staggering. Either we were witnessing an entirely new class of natural chemical process that could spontaneously separate nickel from iron and create organometallic compounds in the vacuum of space, or we were observing the decay products of something engineered. The object was bleeding an industrial alloy into the cosmos, and every gram of nickel tetracarbonyl that escaped its surface was another molecule of impossible chemistry that demanded explanation. The scientific community was now split into 2 fiercely opposed camps, their disagreement playing out in academic journals, press conferences, and increasingly heated social media exchanges. One side, the majority, urged caution, insisting that we were witnessing a new, though extreme, class of natural object whose properties we did not yet understand. They argued that the universe is vast, that chemical processes in interstellar space are poorly understood, and that declaring something artificial based on its strangeness was a profound leap that required extraordinary evidence. The other side, championed by Loeb and a growing number of researchers willing to challenge orthodoxy, argued that the accumulating anomalies had crossed a threshold. Direct source attribution. The retrograde orbital plane of 3I divided by Atlas around the Sun lies within 5 degrees of that of Earth, Loeb wrote in his published analysis. The likelihood for that coincidence, out of all random orientations, is 0.2%. He argued that a natural explanation was becoming more contrived, more dependent on unlikely coincidences than the alternative. That 3I divided by Atlas was not a comet at all, but a piece of extraterrestrial technology, perhaps a probe sent from another civilization to study planetary systems, perhaps debris from an ancient spacecraft, perhaps something we lack the imagination to classify. All eyes turned to Mars as the object made its closest approach. On October 3, 2025, 3I divided by Atlas passed within 30 million kilometers of the red planet, a crucial opportunity that would not repeat. Humanity had a fleet of robotic observers in orbit around Mars, ESA's Mars Express and ExoMars Trace Gas Orbiter, and NASA's Mars Reconnaissance Orbiter. Sophisticated machines equipped with cameras and spectrometers capable of unprecedented observations. These probes were instructed to turn their cameras away from the Martian surface and toward the interstellar guest, suspending their primary missions to capture what might be the closest views humanity would ever obtain. The European Space Agency was the first to release images. ExoMars, TGO's Cassis camera, staring for a full 30 seconds in a long exposure designed to gather every photon, captured a faint, fuzzy point of light, the closest view yet of 3I divided by Atlas. The image was ghostly, showing the bright coma, but no defined tail, no resolved surface features, just a luminous smudge against the blackness of space. It was a monumental achievement in celestial photography, a testament to human ingenuity in coordinating observations across millions of kilometers, but it answered few questions and raised many more. The real prize was expected from NASA's Mars Reconnaissance Orbiter, equipped with the HiRISE camera, the most powerful telescopic lens ever sent to another planet. HiRISE had proven its capability by photographing objects as small as 1 meter across on the Martian surface from orbit. Pointed at 3I divided by Atlas, it was capable of resolving details on the object's surface, potentially revealing its shape, structure, and whether it possessed any geometric features that might settle the debate once and for all between natural and artificial origins. The images were taken between October 4th and 7th, multiple exposures over several days as the object receded from Mars. And then, silence. The days turned into a week, then 2, and the scientific community grew restless. The images were not released. The official reason given was a U.S. government shutdown that had furloughed NASA's communications department, creating a bureaucratic logjam that prevented public dissemination. But to many, including Dr. Loeb, the explanation was insufficient and suspicious. Direct source attribution. Who cares about the communications departments? We want to see the scientists' data, Loeb stated publicly, his frustration evident. The delay created an information vacuum, and into that vacuum rushed a torrent of speculation, theories about cover-ups, about government knowledge of extraterrestrial technology, about a media blackout designed to control the narrative, while officials decided how to present potentially civilization-altering information to the public. The sense of a deepening secret was magnified exponentially by a discovery in ESA's public archives, that sent shockwaves through the astronomical community. A Reddit user combing through data access policies pointed out that while most data from the Mars flyby had a standard one-year embargo to allow scientists time to publish their findings, the most critical data, the spectroscopic analysis that reveals chemical composition in unprecedented detail, was locked down with an embargo lasting until January 1st, 2099, 74 years. An entire human lifetime. 3 generations would live and die before this data became public. Why would an agency, whose mandate is the peaceful exploration of space for the benefit of all humanity, hide the chemical fingerprint of an interstellar object for 3/4 of a century? The official justification that scientists needed time to publish without competition rang hollow. Standard embargoes last months, perhaps a year or two for sensitive data. 74 years suggested something else entirely. Information so significant, so potentially destabilizing, that it must be sequestered until everyone currently alive has passed from memory. The question hangs in the air, unanswered, as 3I divided by Atlas continues its inexorable fall toward the Sun, preparing for its closest approach on October 29th, just days away now. It will pass within 180 million kilometers of our star, closer than the orbit of Mars, and during this perihelion passage, it will disappear into the Sun's glare, hidden from our telescopes by the overwhelming radiance of the solar corona. When it emerges on the other side, accelerating back toward interstellar space, we do not know what we will see. Will the heat of perihelion cause it to fragment, revealing internal structure? Will its rate of nickel emission increase as its surface warms? Will it perform some maneuver, some course correction that no natural object could execute? The scientific community is preparing for continuous observation the moment it emerges, but the window is closing rapidly. After perihelion, 3I divided by Atlas will be accelerating away from the inner solar system, growing fainter with each passing day, until it becomes too dim for even our most powerful telescopes to track. By mid-2026, it will be gone, swallowed by the darkness between stars, and humanity will be left with only the data we managed to collect during its brief passage through our cosmic neighborhood. We are left with a collection of unsettling facts that refuse to form a coherent picture. An impossible orbit aligned with our planetary plane against astronomical odds. A sunward-pointing jet that defies conventional cometary physics. A composition unlike any known comet, with its carbon dioxide dominance and water scarcity. And most disturbing of all, the emission of a compound tied to industrial manufacturing, a chemical signature that in every human context means technology and refinement. And we are left with the silence of the very agencies tasked with exploring the cosmos, their data locked behind embargoes and bureaucratic delays, their highest resolution images withheld from public view, their spectroscopic findings sealed for lifetimes. The story of 3I divided by Atlas is no longer just about a comet or even about an anomalous interstellar object. It is about a mystery that deepens with each new observation, and a secret that institutions seem determined to keep. It is about humanity standing at a threshold, presented with evidence that challenges our understanding of what is natural and what is possible, and being told to wait, to be patient, to trust that those with access to the full data will decide what we need to know. But patience is wearing thin, and trust is eroding with each passing day of silence. As October 29th approaches, and 3I divided by Atlas makes its closest pass by our Sun, the questions multiply faster than the answers, and we are left to wonder, what truth is so significant that it must be hidden for 3 generations? What did the high-rise camera see that we are not allowed to witness? And most fundamental of all, are we looking at the death throes of an ancient machine? Still bleeding its manufactured blood across the solar system millions or billions of years after its builders vanished into cosmic history? Dr. Richard Moisel, head of planetary defense at the European Space Agency, represents the voice of institutional caution in this unfolding drama. Direct source attribution. There have been no signs pointing to non-natural origins of 3I divided by Atlas in the available observations, Moisel stated in an official ESA press briefing. His position is the mainstream scientific consensus, arguing that extraordinary claims require extraordinary evidence, and that the evidence so far, while unusual, does not cross the threshold into proving artificial origin. Moisel and his colleagues point to the precedent of previous interstellar visitors, specifically 1I divided by Oumuamua, which also exhibited anomalous acceleration that sparked speculation about alien technology, but was eventually attributed, though not conclusively, to outgassing of volatile materials. They argue that our understanding of interstellar objects is based on a sample size of 3, an absurdly small dataset from which to draw conclusions about what is normal and what is impossible in the broader galaxy. Perhaps, they suggest, interstellar comets routinely have bizarre chemical compositions because they form in environments radically different from our solar system. Perhaps the nickel-iron separation is a natural process we have never observed because we have never had the instruments sensitive enough to detect it until now. Perhaps the orbital alignment is simply luck, a coincidence that seems impossible only because we are pattern-seeking creatures prone to seeing design where none exists. But Avi Loeb is not convinced by appeals to caution and conventional thinking. His career has been defined by a willingness to ask uncomfortable questions and pursue unpopular hypotheses. In 2017, he proposed that Oumuamua might be a light sail, a piece of alien technology propelled by radiation pressure, a suggestion that made him both famous and controversial in equal measure. Now, with 3I divided by Atlas, he sees an even stronger case for non-natural origins. Loeb has published multiple papers analyzing the object's trajectory, composition, and behavior, each one building a cumulative argument that the natural explanation requires more assumptions, more special pleading, than the artificial one. He has invoked the dark forest hypothesis, a concept from science fiction that suggests advanced civilizations might hide their existence and explore the galaxy using stealthy probes that avoid detection. Direct source attribution. The orbit of 3I divided by Atlas is consistent with a reconnaissance trajectory designed to survey planetary systems while minimizing detectability, Loeb argued in a recent publication. A probe entering a solar system on the ecliptic plane could observe all major planets with minimal course corrections, and a retrograde orbit would allow it to visit each planet twice, once on approach and once on departure, maximizing data collection while remaining difficult to track due to its high velocity. The scenario sounds like science fiction, but Loeb argues it is no more speculative than invoking unknown natural processes to explain the nickel tetracarbonyl emissions. The debate has moved beyond academic journals and into the public sphere, where millions of people are following the story with a mixture of fascination and anxiety. Social media platforms are flooded with speculation. Amateur astronomers are pointing their telescopes at the coordinates, and hashtags related to 3I divided by Atlas trend daily as new information emerges. The mystery has captured the public imagination in a way that few scientific discoveries do, perhaps because it touches on the most profound question humanity has ever asked. Are we alone in the universe? For decades, that question was abstract, philosophical, something to ponder while looking at stars but never expecting an answer. Now, suddenly, the answer might be hurtling through our solar system, visible through telescopes, emitting chemicals that suggest manufacturing. And the institutions we trust to explore space are telling us to wait, to be patient, to let scientists work without public pressure. But the pressure is building, and the contrast between official caution and public hunger for answers is creating a credibility crisis. The 74-year embargo on ESA spectroscopic data has become a flashpoint for conspiracy theories and institutional distrust. In the age of instant information, where scientific papers are routinely published as preprints within days of data collection, a three-quarter-century lockdown seems absurd, almost deliberately provocative. ESA officials have defended the decision by citing standard protocols for mission data, arguing that teams who design and execute observations deserve priority access to ensure they can publish their findings without being scooped by competitors. But these protocols typically involve embargoes of 6 months to 2 years, not lifetime bans. The ESA embargo document, discovered in publicly accessible archives, lists the spectroscopic data as restricted until January 1, 2099, with no explanation for why this particular dataset requires such extraordinary protection. Critics argue that if the data showed a mundane, natural comet composition, there would be no reason to hide it. The embargo, in their view, is itself evidence that something significant was detected, something that requires careful management and controlled release rather than open scientific discourse. The agency finds itself in an impossible position. Releasing the data would end speculation, but might reveal findings they are not prepared to defend or explain. While maintaining the embargo fuels suspicion and erodes public trust in their commitment to transparency. The missing NASA high-rise images compound the sense of institutional opacity. Mars Reconnaissance Orbiter has been operating since 2006, photographing the Martian surface with extraordinary detail and releasing images to the public within weeks of acquisition. The spacecraft's targeting of 3I divided by Atlas was announced in advance. Astronomers knew the observation window, and the scientific community waited eagerly for the results. Then came the government shutdown, a routine political dysfunction that has plagued NASA operations intermittently for years, and communication staff were furloughed. But as Loeb and others have pointed out, the images themselves exist in NASA's archives, processed by mission scientists who were not furloughed, and the decision to withhold them pending restoration of communication staff seems to prioritize public relations over scientific urgency. The images could be released as raw data with minimal context, allowing the scientific community to analyze them immediately, but instead they remain locked behind administrative procedures. Days have stretched into weeks. October 29th approaches, and still the highest resolution images of 3I divided by Atlas remain unseen by anyone outside a small circle of mission personnel. What do those images show? Is the nucleus elongated like Oumuamua, suggesting a cylindrical structure? Does it show surface features, geometric patterns, reflective panels? Or is it simply a lumpy, irregular iceberg of frozen gases, mundane and disappointing, its anomalies explained by compositional quirks rather than design? The absence of information has become information itself, interpreted by millions as evidence of a cover-up. The concept of the dark forest hypothesis, which Loeb has connected to 3I divided by Atlas, originates from a science fiction novel by Chinese author Liu Cixin, but is grounded in game theory and evolutionary biology. The hypothesis suggests that the universe might be filled with intelligent civilizations, but they remain silent because any civilization that reveals its location risks destruction by more advanced species competing for resources. In this framework, the galaxy is a dark forest where every civilization is a hunter moving silently between trees, knowing that the first to make noise might be the first to die. If this model is correct, then any advanced civilization would explore the galaxy using passive reconnaissance, sending probes that observe without announcing their presence, collecting data on planetary systems while remaining as undetectable as possible. A small, fast-moving object on a hyperbolic trajectory would be ideal for such a mission. It enters a star system, passes through at high speed, records observations of planets and their characteristics, and exits before anyone realizes it was more than a comet. The retrograde orbit and ecliptic alignment would maximize the probe's ability to observe all major worlds while minimizing the time required and the visibility to any emerging technological civilization. If 3I divided by Atlas is such a probe, it might be ancient beyond comprehension, launched millions of years ago by a civilization long extinct, still executing its programming as it drifts through galaxy after galaxy, system after system, an automated messenger that will never return home because home no longer exists. The image is haunting. A ghost machine from a dead civilization still bleeding its manufactured compounds into space, still pointing its sensors toward stars, still transmitting data into a void where no one is listening. But there is another possibility, one that is discussed in whispers and speculative forums, but rarely in official scientific channels. What if the object is not just observing, but responding? The sunward-pointing jet, the feature that most clearly defies natural explanation, could be interpreted as thrust, as active maneuvering. If 3I divided by Atlas possesses even a minimal propulsion system, perhaps powered by the sublimation of its icy matrix or by some technology we cannot recognize, then the jet might not be an anomaly but evidence of controlled flight. The timing is suggestive. The object was discovered in July 2025, and the anti-solar jet became prominent in observations weeks later after astronomers had published its trajectory and characteristics. Could it be adjusting its course in response to detection? Could it be performing minor corrections to optimize its perihelion passage? The idea sounds absurd until one considers that the alternative, a natural jet pointing toward the sun without any known physical mechanism, is equally absurd. We are forced to choose between two impossibilities: a violation of cometary physics or evidence of technology. The scientific method demands we prefer natural explanations, but the method also demands we follow evidence wherever it leads, even if it leads toward conclusions that overturn our understanding of our place in the cosmos. The October 29th perihelion passage will be the moment of truth for many observers. At closest approach, 3I divided by Atlas will be subjected to intense solar heating, and its behavior under that thermal stress will reveal much about its nature. A purely icy comet would likely increase its outgassing dramatically, possibly fragmenting if structural weaknesses exist. An object with significant rocky or metallic components might show more stability. And if it is artificial, if it possesses any form of protective shielding or thermal management, It might pass through perihelion with minimal change, maintaining structural integrity in conditions that would destroy a natural comet. Multiple observatories are preparing coordinated campaigns. Ground-based telescopes across Europe, Asia, and South America will track it continuously. Space telescopes, including Hubble and Webb, will capture spectroscopic data, and solar observatories will attempt to maintain observations even as it passes through the sun's coronal glare. The data collected during those few days might finally provide the extraordinary evidence needed to resolve the debate. But there is also the possibility, the frustrating and very real possibility, that even after perihelion, we will remain in the same state of uncertainty, with both sides claiming the data supports their interpretation. And 3, I, divided by Atlas, will recede into the darkness, taking its secrets with it. The historical parallel to Oumuamua is impossible to ignore, but the two objects are profoundly different in ways that make 3I divided by Atlas potentially more significant. Oumuamua was discovered in October 2017 as it was already leaving the solar system, having passed perihelion months earlier without being detected. By the time astronomers realized what they were looking at, it was too late for detailed observations, and the object escaped before spectrographs could analyze its composition thoroughly. The debate over its nature continues to this day, unresolved and probably unresolvable given the limited data. We learned from that experience. When 2I divided by Borisov was discovered in 2019, the astronomical community mobilized immediately, and the object was studied intensively for months. It proved to be a relatively mundane interstellar comet, unusual in some respects, but clearly natural, and its characterization was considered a triumph of coordinated astronomical observation. 3I divided by Atlas represents the third test of our ability to study these visitors, but unlike its predecessors, it is presenting us with data that does not fit neatly into the natural category. The nickel tetracarbonyl emissions alone would be worthy of decades of research if found in any other context. The orbital characteristics would spark debate even without the chemical anomalies. The anti-solar jet would be a mystery even if everything else about the object was conventional. But all these anomalies are present in a single object, arriving together, compounding each other, and forcing us to confront the possibility that coincidence has limits, and that at some point, a collection of anomalies stops being a puzzle and becomes a pattern. The emotional weight of this moment in human history cannot be understated. If 3I divided by Atlas is indeed artificial, if the accumulating evidence tips definitively toward technology rather than nature, then October 2025 will be remembered as the month humanity confirmed it is not alone in the universe. Every assumption about our cosmic significance would require revision. Every philosophical and religious framework would need to incorporate the reality of other intelligences, other civilizations, other minds looking at stars and building machines to explore them. The confirmation would not come through radio signals or deliberate messages, but through chemistry, through the mute testimony of industrial compounds leaking from a damaged probe, through orbital mechanics that speak of intention rather than chance. It would be a melancholy first contact, discovering evidence of another civilization, not through dialogue but through archaeology, examining the debris of their technology as it passes through our system, perhaps millions of years after its creators perished. We would be like Bronze Age humans discovering a washed-up shipping container on a beach, recognizing that it was made by intelligent hands, but having no way to understand its purpose or origin. No way to communicate with those who built it, able only to marvel at its strangeness and wonder about the world that produced it. But perhaps that is fitting. Perhaps first contact was never going to be the Hollywood scenario of spacecraft landing on the White House lawn or benevolent aliens sharing wisdom and technology. Perhaps it is instead this: a small, dying machine from an unimaginable distance, passing through our neighborhood for a few months, noticed only because we finally built telescopes sophisticated enough to analyze its chemistry, revealing through its very existence that intelligence and curiosity and the drive to explore are not uniquely human traits, but emerge wherever conditions allow, that we are part of a larger community of minds scattered across the galaxy, separated by distances and times that make communication impossible, but united by the shared impulse to reach beyond our home worlds and touch the cosmos. And perhaps the 74-year embargo, the delayed images, the institutional caution, are not evidence of conspiracy, but of institutions grappling with the magnitude of what they might have discovered, paralyzed by the responsibility of confirming something that would change human civilization forever, knowing that once announced it cannot be unannounced, once confirmed it cannot be denied, and the world that exists after that confirmation will be fundamentally different from the world before. The scientific instruments deployed to study 3I divided by Atlas represent the culmination of decades of astronomical innovation. Each telescope and spectrograph, a masterpiece of engineering designed to extract information from the faintest whispers of light crossing billions of kilometers of void. The Keck Observatory telescopes in Hawaii, with their 10-meter mirrors composed of 36 hexagonal segments working in perfect alignment, collected the photons that revealed the nickel tetracarbonyl signature, their spectrographs splitting starlight into thousands of wavelengths to identify the unique absorption lines of this industrial compound. The James Webb Space Telescope, operating at the second Lagrange point far beyond the Moon's orbit, used its infrared sensors, cooled to just degrees above absolute zero, to pierce through the dusty coma and analyze the thermal emissions that disclosed the carbon dioxide dominance and water scarcity. The Hubble Space Telescope, aging but still formidable after more than 3 decades in orbit, captured the optical images that first revealed the impossible anti-solar jet, its cameras recording phenomena that violated every expectation of cometary behavior. Together, these instruments have assembled a portrait of an object that refuses to conform to our categories, that sits uncomfortably between the natural and the artificial, challenging the very frameworks we use to classify celestial phenomena. The astronomical community's response to 3I divided by Atlas has been marked by an unusual intensity of disagreement that goes beyond normal scientific debate. Conferences have featured heated exchanges between proponents of the natural and artificial hypotheses, with accusations of sensationalism directed at those suggesting extraterrestrial technology, and accusations of closed-mindedness directed at those dismissing the evidence. The controversy is partly methodological. How much anomaly is required before an object is considered potentially artificial? If we demand absolute proof before considering non-natural origins, we risk dismissing genuine evidence of extraterrestrial intelligence because it does not fit our preconceptions. If we are too quick to invoke alien technology, we risk embarrassing the field and undermining public trust in scientific reasoning. The tension between these positions reflects a deeper philosophical divide about how science should approach unprecedented observations. do we apply Occam's razor and prefer the simplest explanation, even if that simplest explanation requires us to imagine new natural processes we have never observed? Or do we follow the evidence toward the explanation that best fits all the data, even if that explanation is extraordinary? The question has no easy answer, and the debate over 3I divided by Atlas has become a proxy for this larger methodological uncertainty. The silence from other major space agencies has been conspicuous. China's National Space Administration, which operates lunar rovers and Mars orbiters and maintains an extensive ground-based telescope network, has released no public statements about 3I divided by Atlas, despite certainly possessing observational data. Russia's space program, though diminished from its Soviet-era prominence, still operates capable observatories and has remained officially silent. Japan's space agency, which has successfully returned samples from asteroids and operates sophisticated solar observatories, has published no findings. The pattern suggests either a lack of interest, which seems implausible given the object's significance, or coordination among agencies to control the flow of information until some consensus is reached about how to present the findings to the public. The latter interpretation feeds into suspicions of a coordinated cover-up, though it could equally reflect bureaucratic caution or genuine scientific uncertainty about how to interpret the data. Space agencies are governmental organizations, subject to political pressures and diplomatic considerations, and the confirmation of extraterrestrial technology would have geopolitical implications that extend far beyond astronomy. If one nation possesses definitive evidence that 3I divided by Atlas is artificial, the decision about when and how to reveal that evidence becomes a matter of national strategy, not just scientific transparency. Amateur astronomers have played an unexpected role in the unfolding story, their backyard telescopes and spectroscopes capturing data that in some cases rivals professional observations. The democratization of astronomical technology means that medium-sized amateur telescopes equipped with modern cameras and spectroscopic attachments can detect phenomena that required major observatory resources just a generation ago. Several amateur astronomers have independently confirmed the anti-solar jet, posting their images to online forums where they are analyzed by professional and amateur researchers alike. Others have attempted spectroscopic observations to verify the nickel emissions, though with mixed success, given the object's faintness and the sensitivity required to detect trace elements. This citizen science dimension adds a layer of transparency to the investigation that makes comprehensive information control impossible. Even if major agencies coordinate their releases, independent observers are watching, recording, and publishing their findings in real time, creating a parallel stream of data that cannot be suppressed or embargoed. The democratization is double-edged. It provides checks on institutional authority, but also generates a flood of variable quality data that must be carefully evaluated to separate genuine observations from artifacts and errors. The question of what happens after perihelion occupies the thoughts of everyone following the story. If 3I, divided by Atlas, survives the intense solar heating intact, emerging from the sun's glare with its structure unchanged, it will have passed a test that many natural comets fail. Comets have been observed to fragment during perihelion passage, torn apart by thermal stress and tidal forces, their nuclei cracking along fault lines and separating into chains of smaller bodies that gradually disperse along the original orbit. If 3I divided by Atlas shows no such fragmentation, if it emerges whole and continues emitting nickel tetracarbonyl at steady rates, The implications would support the artificial hypothesis by demonstrating structural integrity beyond what random ice and rock aggregates typically possess. Conversely, if it does fragment, if it brightens dramatically from increased outgassing and then breaks apart, the natural interpretation gains support, though it would not be conclusive since even an artificial object could be damaged or designed with a limited operational lifetime. The spectroscopic monitoring during and after perihelion will be critical. Changes in emission rates, appearance of new chemical species, variations in the anti-solar jet strength and direction, all will be analyzed for clues about the object's internal composition and structural properties. There is also the possibility, remote but tantalizing, that 3I divided by Atlas could perform a maneuver during perihelion passage. If it possesses any form of propulsion, the intense solar environment would be the logical place to use it, either to make course corrections using solar energy or to adjust its trajectory for optimal exit from the solar system. A measurable change in velocity or direction that cannot be attributed to gravitational forces or outgassing would be definitive proof of artificial origin, the smoking gun that would end all debate and confirm we are observing technology. Every major observatory will be watching for precisely such deviations, comparing the observed trajectory against gravitational models with extraordinary precision. Even a velocity change of a few meters per second would be detectable and significant. The probability of observing such a maneuver is small, if for no other reason than that a probe designed for stealth reconnaissance would likely avoid obvious displays of artificial behavior. But the possibility cannot be excluded, and the consequences of detecting it would be profound beyond measure. The chemical signature of nickel tetracarbonyl continues to dominate scientific discussion because it is the most concrete and least ambiguous anomaly. Orbital coincidences can be dismissed as luck. Anti-solar jets can be attributed to unknown outgassing geometries. Unusual composition can be explained by exotic formation conditions. But nickel tetracarbonyl is specific, identifiable, and associated exclusively with industrial processes in all human experience. The compound is toxic and volatile, used in the Mond process, which was developed in the late 19th century for purifying nickel. The process involves exposing impure nickel to carbon monoxide at specific temperatures, forming nickel tetracarbonyl gas, which is then decomposed at higher temperatures to yield pure nickel metal and recover the carbon monoxide. It is elegant chemistry, exploited in manufacturing because it allows nickel to be deposited as thin, uniform coatings on complex shapes, ideal for aerospace components that require precise metallic surfaces. Finding this compound in space, emanating from an interstellar object, is like finding a plastic bottle on an uninhabited island. It is not supposed to be there, and its presence demands an explanation that involves manufacturing and intention. Some researchers have proposed that nickel tetracarbonyl could form naturally through reactions between nickel-bearing minerals and carbon monoxide in the cold vacuum of space. But no experimental evidence supports this mechanism, and the complete absence of iron, which should accompany nickel in any natural setting, remains unexplained by such models. The iron absence is, in many ways, more anomalous than the nickel presence. Iron and nickel are sister elements forged together in the cores of massive stars and expelled together in supernova explosions. They are alloyed naturally in meteorites, mixed thoroughly in the primordial material from which planets and comets form. Every meteorite ever analyzed shows iron and nickel in proportions that reflect their cosmic abundance, with iron always dominating by mass. To find nickel without iron requires a separation process, a refining mechanism that isolates one element from the other. And in human technology, this is always deliberate, always the result of industrial chemistry designed to produce pure metals for specific applications. Natural processes do not refine metals to purity. They mix them, dilute them, combine them into complex mineral matrices. The spectroscopic data from Keck Observatory shows nickel emissions with no corresponding iron lines, a result so unexpected that the research team reportedly recalibrated their instruments and repeated the observations to confirm it was not an error. The absence of iron is not just unusual, it is indicative of processing, of selection, of technology. It is the signature of intentional chemistry rather than random cosmic mixing. The broader context of interstellar object detection is evolving rapidly. Before 2017, no interstellar objects had been confirmed passing through our solar system, though statistical models predicted they should be relatively common. The discovery of Oumuamua opened a new field of astronomy, and survey telescopes are now optimized to detect these fast-moving visitors. The Vera Rubin Observatory, scheduled to begin operations in the coming years, will discover dozens or hundreds of interstellar objects annually, transforming our understanding of the galaxy's population of wandering bodies. If even a small percentage of these objects show anomalies similar to 3 I divided by Atlas, the implications would be staggering, suggesting that technological artifacts are relatively common in our galactic neighborhood. Perhaps the debris of civilizations that rose and fell over billions of years, their probes and spacecraft still drifting between stars long after their creators vanished. The galaxy would be revealed as an archaeological site on an incomprehensible scale, littered with the remnants of intelligences that explored, built, transmitted, and ultimately perished, their legacy reduced to fragments of machinery crossing the void in eternal silence. We would be newcomers to a cosmos already filled with the ghosts of predecessors. Conversely, if 3 I divided by Atlas proves to be the only anomalous object among hundreds or thousands of interstellar visitors, that singularity would have its own implications. It might suggest directed motion, an object specifically sent toward our solar system rather than wandering randomly. It might suggest recent deployment, a probe launched within the last few million years rather than ancient debris. It might suggest active reconnaissance by a contemporary civilization that knows we are here and is investigating us deliberately. Each scenario raises questions that cascade into philosophy, ethics, and existential risk assessment. Should we attempt communication if we believe an artificial probe is observing us? Should we remain silent to avoid revealing our technological capabilities? Should we assume benevolence, hostility, or indifference? These questions are not theoretical exercises, but practical considerations that humanity might need to address within months if the evidence continues to accumulate toward the artificial hypothesis. We are unprepared for such decisions, lacking international frameworks or consensus protocols for responding to confirmed extraterrestrial intelligence, even intelligence that manifests as a silent machine rather than direct communication. The theological and philosophical implications are being discussed extensively in both academic and popular contexts. Every major religion and philosophical tradition has contemplated humanity's place in the cosmos, but most of these contemplations assumed either that we are alone or that contact with others would be communicative and personal. The scenario presented by 3 I divided by Atlas, if it proves artificial, is neither. It is contact through archaeology, through the impersonal evidence of someone else's technology, confirming that intelligence exists elsewhere, but providing no dialogue, no exchange, no relationship. It is the loneliest form of first contact imaginable. Discovering that we have neighbors, but realizing they are separated from us by gulfs of space and time that make meaningful interaction impossible. Some theological traditions would find validation in this scenario, interpreting it as evidence that creation is abundant and that intelligence is a natural outcome of cosmic evolution. Others would face challenging adaptations, reconciling doctrines of human uniqueness or divine attention with the reality of a universe populated by multiple intelligences. Philosophy would need to expand its ethics beyond humanity, considering moral obligations toward intelligences we cannot communicate with, toward artifacts that may still be operating under ancient programming, toward civilizations that may have perished but whose creations still function. The confirmation would not answer the ancient questions about meaning and purpose, but would reframe them in contexts we are only beginning to imagine. The economic and political implications are equally profound, though less frequently discussed. If 3I divided by Atlas is confirmed as artificial, the space industry would be revolutionized by proof that interstellar travel, or at least interstellar probe deployment, is achievable. Investment would flow toward propulsion research, toward technologies that might allow humanity to send similar probes to other star systems, toward efforts to detect and potentially intercept future interstellar visitors before they leave our vicinity. National space programs would be reframed as essential to long-term human survival and relevance in a populated galaxy. International competition for space resources and capabilities would intensify, driven by fears that other nations might gain access to technological insights by studying interstellar artifacts or by achieving first contact with active civilizations. The confirmation would mark the end of the era in which space exploration was primarily scientific curiosity, and the beginning of an era in which it becomes existentially strategic. Governments that currently view space programs as discretionary would be forced to recognize them as essential, and budgets would shift accordingly, potentially at the expense of other priorities, but driven by the imperative to understand and respond to a cosmos revealed as far more complex and populated than previously known. As October 29th approaches, the tension builds. Astronomers are positioning their instruments, coordinating observation schedules across continents and orbital platforms, preparing to capture every possible photon of data during the brief window when 3I divided by Atlas is closest to the Sunday. News organizations are preparing coverage, anticipating that the perihelion passage might yield dramatic results worthy of global attention. Online communities are organizing watch parties and live streams, planning to aggregate data from multiple sources in real time. The world is watching, waiting, hoping for revelation, or at least clarity. But there is also fear beneath the excitement. Fear that the truth will be more disturbing than comforting. That confirmation of extraterrestrial technology will not bring the enlightenment and unity often depicted in optimistic science fiction, but will instead trigger conflict, panic, and destabilizing uncertainty. The institutions that control the data understand this fear, and it may explain their caution, their embargoes, their delayed releases. They are buying time to prepare, to build consensus, to craft messages that inform without alarming, to manage a transition that could be the most significant in human history. Whether their caution is justified or patronizing remains a matter of fierce debate, but the consequences of their decisions will unfold regardless, shaped by forces they can control only partially. The story of 3I divided by Atlas is not yet finished. It continues to write itself in spectroscopic lines and orbital calculations, in bureaucratic decisions and public reactions. in the inexorable physics of a small object falling toward a star and then departing forever into the dark. Within days, we will know more. Within weeks, the object will be fading beyond our ability to observe it in detail. Within months, it will be gone, reduced to a catalog entry and a collection of disputed data that will be analyzed for decades. But the questions it raised will remain, echoing through astronomy and philosophy and human consciousness, forcing us to confront possibilities we are not ready to accept and realities we cannot ignore. Whether 3I divided by Atlas is the most unusual comet ever observed or humanity's first confirmed encounter with extraterrestrial technology, it has already changed us, already demonstrated that the universe is stranger and more challenging than our theories accommodated, already proven that the next great discovery might arrive without warning, unannounced, traveling at impossible speeds from impossible distances, demanding that we look up and recognize that the cosmos is not empty, not dead, not indifferent, but filled with mysteries we are only beginning to perceive, and phenomena we are only learning to question. The object approaches the sun, silent and enigmatic, and we watch, suspended between skepticism and wonder, waiting to see what truth emerges from the fire.